What are the lessons we can learn from Log4Shell? And could a zero trust strategy prevent or minimize the damage? These are the questions we're going to explore and answer today. Thanks for tuning in. My name is Venki Raju and I'm the Principal Solutions Architect at ColorTokens. And I'll kick things off with an overview of the exploit and a live demo. We'll then review preventive techniques based upon zero trust principles and follow up with another live demo, but this time in a zero trust environment. So how does this work? The attacker sends an HTTP request containing a special JNDI URL to the application. The request must be reasonably valid so that the application actually processes it and triggers logging using Log4j. Of course, the exploit only works on specific versions of Log4j, and the application must include the JNDI URL in the log. Now, the JNDI URL points to an LDAP server controlled by the attacker. At some point, the application invokes the Log4j library and logs the request. The JNDI data in the log triggers Log4j to contact the LDAP server controlled by the attacker. The LDAP response redirects Log4j to a malicious Java class, which is then retrieved by an HTTP request. The Log4j library then executes the malicious Java class. The attacker can have this class fetch additional malware payloads or initiate a reverse shell for an interactive session like I've shown here in step 6. Now this leads to a bigger problem though. The attacker can scan the environment and discover new targets and then upload custom crafted malware to exploit these additional systems. I'm sure you've heard enough of lateral movement, so we'll leave it at that. Now let's look at the exploit in action. I'm using a couple of open source projects as the basis for both the vulnerable application and the attack server, and my sincere thanks to the authors for contributing these to the open source community. And here we are in the demo environment. On the left of the screen is our attacker station. I've got 3 windows here. So we're going to be running the injection command from this little window here. You can see the curl command pointing to the vulnerable application server. It's actually going to be running on port 10,080. And you can see that the JNDI string is actually being passed inside this XAPI version header. And the LDAP URL is pointing to the attack server, which is actually the same system as we're on here. And we will eventually be invoking a reverse shell. And I'm just, for convenience, putting all of this into one command. The reverse shell is pointing back here as well. The JNDI exploit server is running in this window, again on the same machine. So you can see I've built this from source from GitHub, and I will be running this command in just a minute. Now the reverse shell is down here. It's just a simple reverse shell listening using Netcat, running on port 12345. Now over to the right is the victim server running the vulnerable application, also built off of the open source application I talked about. And we will be running this as the user www data, so just to distinguish it from Ubuntu, since we'll be running as Ubuntu on the attack server as well. So let's go ahead and start both of these up. So there's the vulnerable application running, and here's the exploit server. The exploit server is listening on 1389 for LDAP, and of course for HTTP just on port 8080. And as we mentioned before, the vulnerable application on the right is listening on port 10,080. So let's go ahead and give this a whirl. So I've run the command here. It's returned hello world as a string, which you can see is what was being delivered by the application. And over here down at the bottom, we can see that we've got ourselves a shell. So that's our shell running as www data and on the victim machine. And let's just run a few commands. The host name, you can see we're running on the victim. Check who we are, and you can see we're running as www data. And we can also run some commands to look at our network configuration. So this is where we are on a 10.0.1 subnet, and I've gone ahead and done some recon, and I found out that there is a 10.0.2 subnet as well. And what I'm going to do now is actually do a scan for databases using Nmap. So let's run that. We'll just ignore host scanning and search for just MySQL. Look for open ports on the 10.0.2 subnet, and I'm just scoping it to just the last four addresses. Okay, so you can see that we have found a few databases here, and I could then go on and look for other vulnerabilities in, say, MySQL and perform some lateral movement attacks as well. Now, there's a lot more we could do here. Things like privilege escalation to get, say, root or system access, scan for additional vulnerabilities either on this system or on other IPs that we discover, and so on. But it's time now to look at the attack from the victim organization's point of view. And for that, we're going to use a couple of ColorToken solutions. I've deployed ColorTokens XShield and XProtect solutions in the environment, and they are both running in an observation mode, so I could demonstrate the Log4Shell exploit. XShield is a micro-segmentation solution that includes a powerful visualizer, and we're going to use it to examine the attack traffic. XProtect is a process control solution for locking down servers and endpoints, and also provides visual process execution graphs. We are now in the XShield visualizer, and over on the left is the victim server running our vulnerable application, and our attack server is over on the right, coming in from the public internet. Now let's take a look at the attack traffic that took place. So I'm going to go ahead and select this traffic line between the systems. And you can see that from our attack server, we initiated a TCP connection over on port 10,080. And here's the traffic in the other direction. Specifically, this one's the LDAP, traffic to the LDAP server on port 1389 that was then redirected to fetch the malicious Java class on port 8080, which you can see here. And finally, a reverse shell that went outbound from the victim back to our attack server on port 12345. Now, of course, you can actually, XShield gives you the ability to look at details of any traffic flow, so that's pretty cool as well. So you can actually see the data that went in and out, so it gives you the ability to do some forensic analysis as well. Now let's go ahead and take a look at the process level flow that occurred as part of our exploit. So I'm going to switch over to XProtect, and specifically I'm going to look at the processes that resulted in spawning bash. So let's take a look at this here, and let's go ahead and expand this so you can actually get a view of everything that occurred. Now here's, so it kind of began here. So this is the bash session that I used to actually launch the application. And if you recall, I actually ran the application using sudo and changed the username to www.data. So that's over here. Now this launched the Java process as this user here. And once we performed the attack, the Log4J library actually spun off this bash process, and you can clearly see the reverse shell that we instantiated using devtcp over to our attack server. And this final bash process here is just basically the part of the reverse shell command to just get me an interactive session. So there you have it, a very clear visualization both at the network level from XShield as well as a process level from XProtect, giving you the gory details, if you will, about how this exploit took place. Now let's discuss how Zero Trust can help proactively defend against Log4Shell. The first technique is implementing egress filtering controls. In keeping with Zero Trust principles, we should ensure that outbound HTTP access is only allowed to approved destinations. If this control were in place, the Log4Shell exploit would be unable to connect to the attack server and download the malicious Java class. Of course, we could take this a step further and disallow any outbound request, and this would have blocked both the initial LDAP request as well as the reverse shell. Now, hackers may use common services like DNS and HTTP for these outbound queries, so in addition to egress filtering, we should look at a couple of other techniques as well. The second technique is process control. You can think of processes like resources in a zero trust framework, so we should not allow arbitrary creation of one process by another. Now, in our example, this would mean that Log4j should not be allowed to spawn a reverse shell process. And last but not least is micro-segmentation. Micro-segmentation ensures that the breach is confined to the segment, often called limiting the blast radius, and also prevents lateral movement between protected and unprotected applications or resources. Now let's rerun the exploit scenario, but this time with XShield and XProtect policy controls in a zero trust enforcement mode. Now the first thing I'm going to do is use process level controls to lock down the vulnerable application and more specifically Log4j from being able to spawn any arbitrary process. As you recall before, Log4j actually was able to spin off a reverse shell using the bash, using bash and the the TCP/IO redirection. So what we're going to do is put in a policy that allows Java to only launch specific child processes, right, keeping in line with zero trust principles. Now, as it so happens, in my case, the application needs to be able to launch a specific helper app. So that's the only process that I'm allowing. And by default, everything else is blocked. So you can see that the process control is allowing this and nothing else, keeping in line with zero trust principles again. And I have gone ahead and enforced this time. Previously, it was in a monitor mode. So let's go ahead and run the exploit again, and we'll come back and see what XProtect can tell us, and you can also see what the result of the exploit is going to be in a second. So let's go ahead and do that now. Okay, so we are back at our terminal windows, and I'm going to rerun the exploit. Alright, so let's see what happened here. Now notice that we did get a shell very briefly here. So there was this, you can see the message here, connection received, and we did get our prompt. So this is the reverse shell, but then it looks like that was terminated, and then we are back on, the prompt here that's just listening on port 12345. So clearly the shell didn't make it, or actually it did, but then it got terminated. So, and you can see I don't have the shell anymore. So let's go back and take a look at the XProtect console to see exactly what happened. All right, let's look at our alerts again. Now, all right, I'm going to take a look at this one since we can see that something was killed here, and let's take a look at this again. Now, as before, there's our command that actually ran the application. Here's the Java process. And let's take a look at bash here. Now you can see this was the reverse shell that was launched by Log4j, but then it was actually killed. And here's the reason: the process is not allowed in the list of allowed children. So you can see that using a proactive approach, you can actually stop Log4j before it actually is able to launch its second stage of attack, if you will, either using a reverse shell or downloading additional malware. Now let's switch to using network controls. I'm actually going to be using XShield to enforce micro-segmentation policies. But as it stands, the way I've defined the policies, they are also going to be implementing some egress controls. So let's actually take a quick look at the policies themselves over here. So you can see I have a policy that allows the microsegment, in this case it's my test lab. It does have access to the internet, but only on port 443 and port 80. So it's actually doing a couple of things here. In addition to the classical microsegmentation controls, it is also implementing some level of egress filtering, specifically disallowing LDAP on 1389 and of course the reverse shell on 12345 as well. So let's see what happens when we enforce these policies and rerun the attack scenario. So enforcing these policies is just going to take a few seconds. Let me go ahead and kick things off. Alright, so this will enforce our policies in about 30 seconds. I'm going to now switch over to our terminal window and we're going to rerun the attack. So we're back at our terminal and rerun the attack. Okay, so notice what happened this time. Actually, this did take a few, actually about a minute or so to occur, because the connection initiated by Log4j takes a little while to time out. You can actually see that here's the connect exception because the connection was timed out. But the application did eventually respond back using hello world that you can see up here on the console. Now notice here that we didn't get even the momentary shell that we got before, and the reason was because even though the bash shell ran very briefly before it was killed by xprotect, the outbound connection never really took place. Now let's take a look at the XShield console and we can actually see these block connections. So here we are on the XShield visualizer again, and let's take a look at the connections between our attack server and the test lab. So you can see here's our inbound attempt right on port 10,080. Now let's expand the reverse connections, and you can see that our reverse connection from the victim back to our attack server was blocked on the LDAP port. And so because of that, none of the others actually occurred. Now, these were actually from our previous sessions, but you can see there's nothing beyond this. So all we had to do was just block the very first outbound connection, and that's all it took. So even though the vulnerable system was compromised, the attacker was not able to take advantage of the exploit. And the combination of using process control techniques as well as network control techniques like egress filtering or micro-segmentation can go a long way in defending yourself against these not only Log4Shell but also the emerging zero-day exploits that I'm sure we'll be hearing about in the days and weeks to come. Well, I hope you found this demonstration both useful and informative. When I use Log4Shell as an example, it is clear that a zero-trust strategy can be very effective against a variety of similar zero-day exploits. Thanks for joining me today, and see you again soon.